baru review. Okay, ulang. Start.
Okay, start.
Okay. Assalamualaikum warahmatullahi wabarakatuh. So today our group going to present about vertical cavity surface emitting laser, VCSEL. So start with abstract. Vertical cavity surface emitting laser, it is used to prevent the loss of transmission in the optical fiber and also used in various optical communication applications such as 3D sensing, LiDAR, automated driving and manufacturing, high-speed data communication, laser printers, optical mice, and smartphones. So this picture is about this device. And proceed to this. The emittance from a single surface enables VCSELs to have the maximum output power possible. Long-term reliability and stability, a uniform wavelength and symmetrical laser beam. The upper and lower mirror of VCSELs are doped as P-type and N-type materials, forming a diode junction. VCSELs are easy to couple with other optical component and a light source of a short distance links, interconnects and networks data transmission.
Next, for the literature review. First, the vertical cavity surface emitting laser or VCSEL have become quite well known, which are formed in a variety of structure. The basis for the laser in virtually all structure is an active area that is in between two mirrors stacked. To active the laser, it is necessary to drive current through the mirror stacks and the active area. Basically, to manage it by inserting a first electrode across the mirror stack at one end of the lace and a second across the mirror stack at the other end of the lace. It will generally define a central opening by one of the electrode there through for the emission of light. Next. So the VCSEL layer has 7 layers. So the VCSEL has the 7 layer. First layer is made by the First layer is made by the a metal layer. So one of the top layer is the electrical contact for the current. Next layer is the high reflectively top mirror, which has almost fully reflectivity or 99% reflectivity. This layer has been built of DBR, or known as a distribute bright reflector. The next layer is an oxide layer, which constructs a light emitting window, and the light beam can optimize into a circular beam. Next, for the center layer is the laser cavity, which is typically a multiple quantum well layer. The bottom of the center layer is another oxide layer to confine the light. The last layer is the bottom of the DBR layer, which has 99.9 reflectivity. The observation is the reflectivity is much higher than the top mirror, so that the lasing light will get out from the top mirror instead of bottom.
Then the quantum well structure. The quantum well produce photons which get bound back and forth between the top DBR mirror P dot and the bottom DBR mirror M dot. Active region in a VCSEL laser is usually a quantum well structure. This configuration can be repeated several times to build a multiple quantum well. Each structure is made of 3 layers, which contain two aluminum, gallium, and arsenide layer. The between of layer top and bottom contain two aluminum, gallium, and arsenide that are very thick compared to the top and the bottom layer which are thick. The fact that electron cannot move freely in the vertical z direction but only in the xy plane. So this is called quantum confinement, and it effective by increase the lasing efficiency, which is a big advantage over conventional double heterostructure lasers. The advantage of VCSEL. Basically, VCSEL consists of two oppositely dots assigned by red reflector DBR with a cavity layer between. The center of the cavity layer resides an active region consists of multiple quantum wells. So the current is injected into the active region via a current guiding structure or provided by an outside aperture or proton implanted surrounding. Plus, the entire cavity can be grown with one step epitaxy. This presents a significant manufacturing advantage. The second advantage is the visual cavity is very short, more shorter than that of a typical emitting laser. Then the VCSEL can initiate light source for data transmission in short distance link, interconnect, and for local network LAN. And the structure can be integrated in two-dimensional array configuration. Low cost potential because the devices are completed and tested at the water level. Lower temperature sensitivity compared to its emitting laser diode. High transmission speed with low power consumption. VCSEL has more high efficiency and high performance compared to other.
So we start to the next is the discussion. In terms of the threshold current emission spectrum. Oh, sorry. Emission spectrum, temperature characteristic, as well as dynamic and noise activity. The previous discussion showed that selectively oxidized VCSELs have excellent properties. The analysis provides important guidance specifically for applications requiring high speed modulation for optimizing system efficiency. Multi-mode VCSELs can supply tens million watts of output power and can be combined to produce watt-level outputs from small area chips into dimensional arrays. So continuous wave activity above 118 18 degree Celsius ambient temperature, where material dependent gain and carrier loss from the activity region are limiting effects has been demonstrated. Using linearly polarized single mode VCSELs emissions see error free data transmission rates of up to 12.5 gigabytes over single mode fiber and silica glass or plastic optical multi-mode fiber were obtained. At the million watts power level over a frequency range exceeding 10 gigabyte system specifications. Single frequency devices have been shown to surpass the short noise limit of the relative intensity noise spectrum. The findings suggest that VCSELs outperform edge-emitting laser diodes in many respects. In the 800 to 1000 nanometer wavelength regime, these devices have already become the dominant transmitter source for commercial high-speed optical interconnects, and the emergence of 1.3 and 1.55 micrometer long wavelength VCSELs on the market is eagerly awaited. We can continue with Lokman to present our conclusion.
Okay, so for the conclusion, what can we conclude is VCSEL is nowadays the use of this device is increasing days by days, years by years. The application of this technology is also keep spreading of to many places around the world as it is very convenient and suitable with our current modern life. Small size of the ability to fabricated into the arrays, integration ability with other components. And VCSELs is significantly easy to test and manufacture, which make many people most likely to get use of it. They are also used in more niche application areas such as optical clocks and as solid state laser pumps. These high power VCSEL systems offer versatile solution for heating and SSL pumping application. Progress in the field of high-speed VCSELs will definitely continue growing, leading to further exciting results. For example, VCSELs with photonic crystal or high contrast gratings, as well as indirectly modulated VCSELs, and even exciting novel metal cavity knowledges based on VCSELs like structures, and currently intensively investigated and certainly will generate significant knowledge and very high value for both fundamental science as well as application-oriented research. So that's all from us. Thank you.
Woo! Dah
Itulah.
habis.
Itulah.
Setelah